Notes 2.1, we're going to be looking at laws of logarithms. They're very similar to laws of exponents, which we recently went over. So notice that it says if m, if m and n are positive real numbers, and b is a positive number other than 1, then these laws are true. Okay? Alright, so it tells us that on number 1, notice that m and n here, we are multiplying them. So when you multiply, you can rewrite that as two different logs by adding those two terms. So the base always stays the same, just like on exponents. So when you multiply, it's the same thing as adding the two logs. When you're dividing on number 2, same thing as subtracting. On 3, if the log base b of m is equal to log base b of n, all you have to do is set your m equal to n. So you can just drop those logs because you know that they are equal. That's what that equal sign means in the middle. Okay. Then law 4, it tells us that if we have an exponent with a log, we can rewrite it as a coefficient in front. That's what that meant there. K log base b of m. Okay, k has to be a real number. And then law 5 is the change of base formula. Remember we talked about last unit. You can only type in a common log on the calculator or natural log because it has a base 10. So there's a formula that you can use to change it to base 10 and evaluate it on the calculator. So log, you would take log of c divided by log of b. Okay, so we're going to look at the difference between laws of exponents and laws of logarithms. So on the first one, we're multiplying. When we multiply, we add the exponents. So that would be x to the 5th. If you look over to the right on your logarithms, notice that we're multiplying x and y. We can also add those. So log of x plus log of y. So very similar to laws of exponents. On this next one, we're dividing, so we subtract the exponents, which will be x cubed. On the next one, we're dividing, so we can subtract the logs. We'll do log of the numerator, so x, minus log of the denominator, which is y. Okay, so here we're going to be multiplying those exponents, so that would be x to the 10th. On your logarithm, you can just put it in front and multiply it by that log. So that would be 2 log of x. So you can just multiply it and put it in front, make it a coefficient. Alright, so now we're going to use these laws of exponents. It says expressed in terms of log of m and log of n. What that means is expand, which means write it in multiple logs. So we're wanting to expand it. Okay? So notice we're dividing on number 1, so we're going to break it up by subtracting. So log of the top, which is m, minus log of the denominator, which is n squared. And then once you get to that point, when you're expanding, make sure that you put that exponent in front. So that would be log of m minus 2 log of n, and that would be our answer. So this is just another way of writing logs. Just like with laws of exponents, another way. Okay, so notice on number 2 that we're multiplying m and n squared. So when we multiply, we can add the logs. So log of m plus log of n squared. And then the same thing that we did on number 1, make that exponent a coefficient and multiply it in front. So that would be log of m plus 2 log of n. So that is expanding. We will be using that. We'll be using that when we get to solving the equation. If you look at 3, we are expressing as a single logarithm, which means you're going to condense. So that means we're going to put it in one log form. Okay, we're wanting to get it to where it only has one log. But notice that it says we're putting in a single logarithm or a rational number. So if you can actually evaluate it at the end, make sure you go another step. Okay, so notice that we're subtracting the two logs. Before I can do anything with that, notice I have a coefficient. I need to make that an exponent. So that would be 27 to the 1/3 power. So when we're subtracting to condense, we're going to divide log base 2, base never changes, of the first term, which is 48, divided by 27 to the 1/3 power. Remember when we talked about 1/3 exponent, 1/2 exponent, 1/4 exponent? You're taking that root. So this 1/3 exponent means we're going to take the cube root of 27, which we know equals 3. So 48 divided by 3, we're going to get log base 2 of 16. And then that would be my answer, but notice we don't have any variables in our log term, so we're going to evaluate. We just went over how to evaluate last unit. We're going to do around the world. 2 to what power equals 16. So that answer would equal 4. So 2 to the 4th equals 16. So answer, we get an answer on that one. If it had a variable in your log, you could have just left it like that. But since it had log base 2 of 16, we had to evaluate it there. Okay, 4, notice we have parentheses, we're condensing it into 1. I would say wait to distribute that 1/2 until after you've condensed the inside. So I'm going to rewrite the 1/2. Notice that I'm adding those two, so to condense it, I'm going to multiply them, m times n. And then I'm subtracting the p. Whatever you subtract goes in the denominator when you're condensing. So I'm going to divide that by p. So notice I condensed it into 1 log. Now, I'm going to distribute that. And we're doing the opposite of what we were doing on the front. So that coefficient I'm going to make as an exponent to all of that. So now that's log base b. Anything to the 1/2 power means square root, so I want you to put mn over p under that radical. Since we have variables, we will leave it in that form, so we can't actually evaluate it there. Alright, 5 we're evaluating, so this is what we did last unit. Of a natural log, we have base e. To what power gives us e to the 4th? So answer would be 4. It gave us that exponent there. Okay, so then the next one, we have a log without a base. That's a common log. We know the base is 10. To what power is going to give me 0.001. I want you to change that to a fraction there. So 0.001, that's in the thousandths place, which would be 1 over 1,000. So remember when we talked about last unit, we're wanting to figure out, we're going from a whole number to a fraction, so we know it's going to be negative. Cover up that top, and notice we're going from 10 to 1,000 if we cover the top up. So we would have to square it. 10 squared is 100, but 10 cubed gives us 1,000. So that would make it -3 in order for it to be 1 over 1,000 there. Alright, the next part, we're going to express y in terms of x, which really just means solve for y. So I'm going to condense this left side. So anytime we're wanting to actually not do that just yet. We're wanting to get y by itself because we're wanting to solve for y. So I'm going to subtract 1/2 log of x. So I have log of y equals log of 3 minus 1/2 log of x. Okay, so we're wanting to get y by itself. So notice we just have log of y on the left side. Remember we talked about on the front, whenever we have one log that equals another log, we can drop those and they should be equal. So I want to condense this right side. So I'm going to make that coefficient an exponent. So when we're subtracting, we divide. So 3 divided by, we have x to the 1/2, which means square root of x. So notice now, since we have a log that equals another log, we know y has to equal 3 over square root of x. So I just wanted you to get y by itself. Okay, the last two, we're going to use change of base formula to find the value of the logarithm. We're going to round to 3 decimal places. So the reason we're using the calculator or change of base formula is because the base is 2. We're wanting to figure out what the exponent would be in order to equal 9. So that would be a decimal there. Okay, so we're going to use change of base formula, which was law number 5 on the front. You can change it to base 10, so that way you can evaluate on the calculator. So I'm going to do log of 9 divided by log of the original base, which is 2. So you have to remember that formula. It's log of this number first, and then log of your base on the bottom. So I'm going to use the calculator, since that's a common log there. So I'm going to do log of 9 divided by log of 2. So you're going to get a decimal. It's going to be 3.1. That would be 70 if we're running to 3. To check it, we could do 2 to that power. It should give us that 9 that we talked about. Okay, so looking at 9. Our base is 4, we want to know our exponent, we want it to equal 6. So we're going to use change your base, so take the common log of 6 over the common log of 4. So log of 6 divided by log of 4. We got 1.292. And then again, if you wanted to check it, you could do 4 to that power, and it does give you 6 there. Okay, so we are going to be using these laws of logs once we get to solving log equations, which will be tomorrow. Okay.